Here we are on class example 7. This is where we left off last day. So a golf ball is dropped from the top of a building 100 meters above a paved road. And in each bounce, the ball reaches a vertical height that is 3/4 of the previous height. So it says determine the vertical height to the nearest tenth of a meter of the ball. And we'll highlight this after the 7th bounce. So when I see this, I would really like to keep it simple in my head, because even myself personally, I kind of get confused. I want this to be T7, because that, to me, that makes sense. After the 7th bounce, I want term 7. So let's try to set it up in such a way that this is going to happen, okay? So here you need to draw like your tower or top of a building or whatever, and then you throw a golf ball down. Okay, the golf ball comes down, and then what happens here? What do we call this spot right here on the ground? Is that the first bounce? Okay, so let's call that T1, because we want after bounces, not before bounces. We want after bounces. So let's call this T1. Would you guys be okay with that? To me, that makes sense. So then what will happen? What will be the height after the first bounce? So it starts at 100. What's the height after the first bounce? 3/4 of 100. So that one's easy. That one's easy, right? And then what happens? Bounces again, and then you get the height after the second bounce. So maybe it would actually be better if we just put, instead of T1 down there, it gets confusing. Let's just put that, first bounce, second bounce. Let's just call these the bounces. And let's put 75 as T1. I think that makes sense, because it's the height after the first bounce. You agree? And then we have our sequence. Okay? So what's T1? 75. And it's not 100, right? And this is where students really find stuff challenging. It's like, well, the first number they give me is 100, so I just want that to be T1. Okay, but you got to think. Okay, so we've figured out what term 1 is. So what would term 2 be? Well, you would just multiply by 3/4, right? 56 something. Thank you, sir. Now you could just keep plugging away like this all the way till you get term 7, and that would be just fine. Let's just use the formula. So the first term is 75. 3/4 is our common ratio. And we need to find power 6 here, because n minus 1, 7 minus 1 is 6. And also because, you got to multiply by r 6 times to get to T7. And hopefully that makes sense. In our calculator, this comes out as, someone help. Make sure you do your exponent first. 3/4 to the 6 in a bracket times 75. 13.3. I love it. Okay. And that's in meters. Okay. Now, that was part of geometric sequences. But what this lesson is on geometric series. We're adding stuff up. And you look in part B, this is where it gets more challenging. We want the total vertical distance traveled by this ball. Okay? So what happens after the first bounce? So I kind of want you guys to just ignore this 100 at first. This initial vertical distance, we're going to just ignore. So you go up, you go down, right? So it's like 75 times 2. And then you go up, and then you go down. So it's like 56 whatever times 2. Right. So let's write a formula for this. You have that initial 100. Do you agree? So let's just put that off to the side, and we got to do these bounces. Okay? So it's going to be 2 times term 1 plus term 2 plus ... all the way up to term. Well, that's where we got to be careful. Back into the reading. What does it say? The total vertical distance traveled by the ball when it contacts the floor for the 7th time. So when it contacts the floor for the 7th time. So we don't want term 7 in there. We have to actually stop at term 6. Okay, so let me draw that again. Let me draw this out for you so it's clear. 1, 2, 3, 4, 5, 6, and 7. So here's the contact at 7. Okay. And I think this was 75, term 1. 56 something, term 2. So term 3, term 4, term 5, and term 6. Contact at 7. So we don't need to include term 7. Do you see that? Really hard to think about on your own sometimes. Especially generating this formula here. It's that initial 100 plus T1 all the way to T6 times 2, because it happens twice. You go up, you go down, you go up, you go down, up and down, up and down, up and down, up and down. So there's 6 ups, 6 downs, plus that 100, right? 6 ups, 6 downs, plus the 100. That's why we only go from T1 to T6. So let's keep going with this formula. 100 plus 2 times. What's another way of writing T1 plus T2 all the way to T6? S6. Okay, so let's go 100 plus 2, then whatever the answer is to S6, we'll put it in there. Okay, and I'm just going to do that up here where I have some space, okay? I'll just do S6 over here. Do we know term 6? So let's use the formula that doesn't need Tn. So how does it go? A r to the n. And then minus 1 is outside the power. I had a lot of people confusing this during the quiz. They're putting the minus 1 in the power, kind of like how the term formula is. So be careful, this is outside on its own, just a number. And then all over r minus 1. Do you guys agree? Okay, plugging this stuff in. I'll zoom in for you. A is not 100, it's... And then we have 3/4 to the n, which is 6, minus 1, all over 3/4 minus 1. Okay, so let's put that in the calculator. Two minutes. Okay, I just jotted it down on a note sticky so I could copy it down into the calculator. So please watch on the calculator. Do you guys like typing it all in at once or a little bit at a time? All at once? Okay, 75. Then we need a left bracket. And then I'm going to put a bracket for r raised to the power 6. And then if you got the nice calculator, you got to get out of the power just by tabbing over. This one does it automatically. And then we will subtract 1. And then I'll close the bracket on the numerator. And because I didn't put an initial bracket, I'm just going to calculate that. That's my numerator. Now I need to divide by the denominator, which in this case is 3/4 Always put a bracket for fractions. 3/4 minus 1. Close that bracket. And I got this 246.6. So that's the value for S6. Okay, so get to know your calculator. Make sure you don't have any issues. Okay, so this was 246.6. And we can go and shove this down into our other formula down here. So times that by 2 and add 100. Thank you. So very doable if you can understand, which term we're talking about, where do we start, contacting the ground, after a bounce, before the bounce. Those little details in the reading will make or break your solution. Like I've seen some of the quiz rewrites people have been doing, you might be off by one sequence number. Your process is perfect, but you might have this, you're off by one term because you just got to read it very clearly. Okay, and if it's like a multiple choice or a numeric, like it's a one shot, you're done, right? If it's written response and I see you've done everything correct, but you're off by a term, I can take off just like maybe a half a mark or something. But these multiple choice numerics, like, they're all in for 1 mark, right? Okay, let's do C. This one's tough. It says, how many times does the ball need to bounce? So what are they looking for? Which variable? No, how many times does it need to bounce? That's n. Or is it n minus 1? Right? How many times does the ball need to bounce to travel approximately 675 meters in vertical distance? Okay, so for n bounces, the total is equal to 100 plus 2Sn. So for 6 bounces, and then underneath put in the bracket seventh contact. Do you remember that? Okay, so let's jump into the formula. This is just to help you remind you from the last page. This was the last page. For 6 bounces, 7th contact. So how many times does the ball need to bounce? N bounces. Okay, the total is 675. 100 plus 2 Sn. Let's just do this algebra. Sn formula. I'll highlight it for you so it's clear. Sn in blue. We're just using our formula in blue here. Okay. So what's the formula for Sn? A, which is, say 5, bracket, Rn minus 1, right? So 3/4 n, and then minus 1 bracket. All over 3/4 minus 1. Sure. A little bit better? Or you want it all the way? Do you have the top 2 lines? I can go all the way. Okay. Better? Okay. And now we have to practice our algebra. So where's the unknown? Way in that blue highlight, right? So you got to isolate the term involving the variable. So this term, all this stuff needs to be alone. So this got to go where? Okay. Quickly do that. 575 equals 2. Now let's clean this up. We got a 75 3/4 n minus 1. Like this. And we can clean up the 3/4 minus 1 if you want. Negative 1/4. What do you guys see now? Hopefully something's popping out at you. How do we deal with stuff like this? Good. The word is cross multiply. This is what should be coming to your head. Where is this negative quarter going? Up. Where's this 2 going? Down. Where's this 75 going? Down. That will unlock this square bracket. Think of it as like unlocking a chest. I need to get in this chest right here, this treasure chest, where the variable is. I need to get in there. So what needs to vanish to the other side? I got to get rid of the 2 and the 75 and the negative 1/4. So the 2 and the 75 is like 150. So you can put a 150 down here. That's gone. And then I could put a negative quarter up here, and then that's gone. It's challenging algebra at first. Once you get used to it, then you're good to go. So, need a calculator. We got 150. No, 575. We're going to times that by negative 1/4 in a bracket, and then divide by 150. This is some random number like negative 0.9583 repeating. And that equals 3/4 to the n minus 1. You can take this, you can go math fraction, and you'll get negative 23. Can someone do that math fraction on this? Anybody? Negative 23 over 24 equals 3 over 4 to the n minus 1. You know, at this point, like, even right off the beginning, you could use your calculator. Like, right here, all this nastiness, you can use your calculator. Type this in, type that in, y1, y2, intersect, okay? But we are trying to do the algebra in 20-1. Okay, we got to go up here and start the next line. Negative 23/4, or 24ths, pardon me. We got to move that minus 1 to the other side as a plus 1, right? So how do you add 1 with the denominator of 24? 24 over 24. Note negative on the right, it'll go over to the other side as positive. This minus 1's coming over here as a plus 1. Yeah, it's negative on the left. Still negative on the left. Negative 23 plus 24 is 1/24. And over here we got 3/4 n. Okay? At this point, still, just like at the beginning, you're still in the same spot. I mean, you've done some really good algebra. You should be proud of yourself. You still have the same issue. I'm not in Math 30. I don't know the logarithm. I got to use my calculator anyway. So use your intersect feature. Intersect. y1 is a 1/24, which is very small, so you need to adjust your window. I would go like 0 to 1 in the y, because this is a fraction. And then y2 is this 3/4 to the n. The answer is 11, 11 bounces. So you're going to need to make sure your window in x gets to 11. And you won't know that the first time. So you'll have to play around with the window. Very, very, very challenging question right here. I'll talk about the test tomorrow. Okay, we just have a couple more to go. Okay, guys? For this question, it's 1A and B that are critical. Okay? And I'll talk about the test tomorrow. Okay, let's jump into class example 8. These are the geometric series general terms. We've seen this once or twice already. Okay? So the sums are generated by this random formula. So you can find S1. And I've seen a lot of people do this in the quiz, so you guys know this stuff. Here's S2. Here's S3. And here's S4. Okay, so we can spit these out pretty easily just by pumping into our calculator. So it's 10, it's 40, it's 130, and this is 400. This is just straight out of your calculator. All we've done is changed the value of n for the first 4 sums. And remember, these are sums, not the actual terms. And I've seen a couple people stop here thinking that they're done. These are the sums, not the terms. And you can see that this question is asking for the first 4 terms. So be super careful with this. These general term sum formulas do not spit out the individual terms. You have to think about this. What would be the first term? This one's easy. 10, because what's the sum of 1 terms? The first one. Now, if you know that the first one is 10, and the first 2 add up to 40, well, this has to be 30. And if the first 2 add up to 40, and you need to add something else to get to 130, this is going to be 90. Good, Emily. Now add up the first 3. Is that 120 and 10 is 130. So something plus 130 is 400 is 270. And even you know it's going to be geometric. This is a hint. How did I go from 10 to 30? You had to times by 3. So you don't even really, once you get the first one, you get these ones for free almost. Okay, so let's just write how I did the first 2. Just how I did the first 2, just so you have a formula. So how did I get the second term? It was S2 take away S1, right? That was how I got the second term. It was 40 minus 10. Yeah. So how to find T9? If it's T2, you need to start at S2. This will be T9 would be S9 minus S8. So how to find the 9th term? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is T9. All those terms added up is S9. That's this. All of S8 is just off there. So if you take the addition of all 9 terms, take away the addition of all 8 terms, you get that 9th term. Okay? Now actually doing it. Now the execution. So we got to use our formula up here. by the star. We got to use that formula. So S9 would be 5 with a 3 to the 9. Subtract S8, that's 5 with a 3 to the 8. This is something I can type right into my calculator, actually all in one line. So I'll just give you the answer. 6, 5, 6, 10. That second line I could type into my calculator. No problem. Ouch. Okay, one more question, which is very, very similar to this part C we just did. This next question is a lot like part C. Okay? So if you're a little bit lost in C with all this algebra, like look at that, that's nasty. If you're a little bit lost in this one, part C, this next one here on the next page is very similar. So you might want to study off this one. We don't do any of the crazy algebra in this one. Okay, so bacteria at the end of the first hour, 30, that's a weird comma, bacteria cells are present. So this to me tells me A is 30. The first term is 30. And then the number of new cells produced forms geometric sequence. In a total of 40,950 cells are present at the end of 6 hours. So again, at the end of the first hour, so this is T1 at the end of the first. So then it says, where is it? At the end of 6, so what are we looking for? T6, right? At the end of the 6th hour. Use technology to determine how many new cells are produced in the 6th hour. Technology is your graphing calculator and the intersection feature. Is that specific? So if you see that, use technology, let's write that in. Use a clock. Okay, technology, let's just put a little note on that technology for you guys. Note, use intersect feature. The hardest part about the intersect feature is the window settings. Okay? Y1's your left side of the equation, Y2's your right side, and then you intersect. And if your windows are screwed up, it might be hard. Okay, so what do we know? Do we know anything? Have we used this 40, 950? What is this? A total? So that's S6. Do you agree? All right. And what's unknown? Sure, T6 is unknown, sure. So we can't use the formula with Tn, right? We can't use that one. So we got to use this, the first one on your formula sheet. So let's jot it down, and what are we missing? R, good. A to the Rn minus 1 over R minus 1. I've wrote it so many times now I've memorized it. Didn't even want to memorize it, but now I do. So we can plug this stuff in. This 4950 goes there, do you agree? A is your first term, which is 30. We don't know R. Do we know N? 6. Minus 1 all over R minus 1. Okay, and they just want us to use technology. Even though I think we could do this one by algebra. Maybe, maybe not. No, you'd have some weird R to the 5 polynomial or something. Okay. Calculator. Please follow along with me so you get used to this technology piece. Okay, I'm just jotting this down on a scrap paper so I can copy it. All right. Okay, left side. Go to Y1. What is it? 4950. And Y2 is the right side. So now this is where we gotta be so careful. Okay? You need a bracket for your numerator, and then divide a bracket for your denominator. Okay, like I have on the whiteboard here. Structure is key. Put in the left bracket. Now I can put in my numerator, which is a 30 outside of a bracket, r to the 6, so x to the power 6 minus 1. And I can close the bracket, and then I can close the bracket on the numerator. Now I divide, open up a bracket on the denominator, and I can put in my r minus 1, which is x minus 1, because we're trying to find r. If you don't have those brackets, you won't have a hope. Now, before we hit window, do not hit graph, because you'll wait 10 seconds, and that sucks. You hit window. How high does our window need to be? Good. Your window needs to get to like that 49.50. So let's just go 50 grand, 50,000. Oh, did I put it in the wrong spot? This is X, right? So let's make sure that 50,000 is in the Y. Now, what is the question even talking about? Bacteria and hours and stuff? So how many hours do you think is even reasonable for this? Yeah, well, let's go 0 to 10. Let's just be careful. 0 to 10. Think about the x values as like the context of the situation. You know, if we're talking about like minutes it takes to drive a car or something, like it's different, right? This is hours in bacteria. So let's press graph and hope for the best. There's that 49.50, and here's that crazy formula. Second trace, 5. Enter, enter, enter. And I got 4. So that's awesome. X is 4. Oh, that's just a computing science thing for the programming of your calculators. If you got this 99999, it's just a programming error. Like that's just how it's done. It's 4. Yeah. Some calculators, yeah. So X is 4. Where is it? Okay. So in this case, X was R, so R is 4. Okay. So now we've figured out what the common ratio is, but we still haven't even answered this question, which says to determine how many new bacteria cells are produced in the 6th hour. So you need to find T6. That was our goal in the beginning, if you remember. So let's do that here. T6, that's what we want. Okay, remember it's A, R, 6 minus 1. So 30, 4, 5. Straight into the calculator, pump it out. My book says 3720. Produced in 6th hour. Okay. Again, I'm finishing lessons like with no time to work. So after this week, I'm going to be strict on the quiz timeline. Like 15 minutes, we're done. So you come in prepared for those quizzes because you need time to work, I think. All right. So this is your homework. I think I signed up to what, 6? So let's go 7. Finish the rest of this 7 to 13, and then you got your 14 and 15 as especially 15 as challenge. 14 and 15 are a challenge if you really want to push yourself. 14 and 15. And these multiple choices and numerics at the end, my server is unreachable. But on the next page, 16 to 19, there's numeric and multiple choice. I really like how this book puts those in there because that's what you always get on your tests. These ones here. So I really like these ones. I would probably do these multiple choice numerics probably like a couple days before the exam, just to prepare myself from each lesson. And these written responses in the homework, this is how you learn the material, all this stuff. Okay, and if you've never used these books before, remember there's always an answer key at the end of each section. So sometimes kids are like, is this right? Well, check the answers. And then if it's wrong, then we can talk about it.